Right, today we're looking at logarithms, or as we just call them, logs. What we're doing today is looking at mainly the log rules and being able to use those. Formal definition: if you've got b to the power of p equals q, then the log of q with the base of b is equal to p. So they flick around. So they're kind of related to exponents in some way. In actual fact, the most useful tool that we will use for logs is being able to solve equations when x is the power. So b is the base, p is the logarithm, and q is the number. So if we're going to write these in log form or index form, okay, so your base is always at the base of your exponent or your power. Okay, so that's always your b, your base. What happens with the other two numbers? They tend to swap over the sides of the equal sign. So we're going to change it to log. The base is 2, the 32 and the 5 have swapped over sides. So if we're writing it in index form, so with exponents, our base is 5, under the power, which is 3, because these are going to swap over, equals 125. So the 125 and 3 have kind of swapped over spots on the equal sign. So if we're going to do these ones here, calculate them, put it equal to x. Okay, put that one equal to x as well. So now we've got 4, which is our base, to the power of x, because these are swapped over, equals 1024. Now with some of these, we actually just guess and check. So if we keep going on the calculator, 4 times 4 times 4 times 4, what we'll eventually find out is that x to the is equal to 5. So 4 to the power of 5 equals 1024. So for this one here, we can swap it around and say, right, 10 to the power of x equals 0.1. Sorry, I'll just scribble out the x there. Okay, another way of thinking about 0.1, 0.01, is 1 over 100. Okay, so which equals 1 over 10 squared. Okay, which, using our index rules that we know, is 10 to the power of negative 2. So therefore 10 to the power of negative 2 equals 0.01, and so therefore x has to be negative 2. So we're going to solve these ones. So x is going to swap over with a 3, our base is 6, so 6 to the power of 3 equals x. And if we put that into our calculator, we get x being 216. Again, we do this kind of the same with this one. Our base this time is x. Our 5 and our 243 spots. So it's going to be x to the power of 5 equals 243. Now to find that on the calculator, use shift and your power button to find out the fifth root of 243, or guess and check, and you'll find that equals 3. Now we're going to do some log rules. Properties of logs. The first one is the log of a times b equals the log of a plus the log of b. The second one is the log of a divided by b equals the log of a minus the log of b. And the last one that we'll look at is the one that we'll probably use most of all, is the log of a to the power of n equals n times the log of a. So n can just come down the front here. So if we look at some examples, if we want to simplify log 4 plus log 6, we're going to use the first rule. So log a plus log b equals log a times b. So we're going to just multiply the 4 and 6 together to get log of 24. We can actually work that out as a number by putting it into the calculator. So the next one is log 27 minus log 9. So we're going to use the second rule for that. So A in this case is 27, B is 9. So 27 divided by 9 is log of 3. Now, letter C here, if you notice there's a 4 outside the log 2. Now we're asked to write this as log of a single number, so it wants log of a number. So we need to deal with this 4. The way to deal with this 4 is using the last rule. And we're going to take our n, or our 4, back in with the 2. So what it becomes is 2 to the power of 4. And if we go 2 to the power of 4 is log of 16, and that's our log of a single number. So if we have a look at these ones. Right, first one here, this 3 log 2 is very similar to the last one we did. So we're going to use BEDMAS, and we're going to take the 3 back into the log part of it. So it now becomes log of 2 to the power of 3. Haven't done anything with the last 2 bits yet because we're going to be using BEDMAS. Now, so that becomes log 8. Now we're just going to take the first 2 bits. So log 8 plus log 4 becomes, remember you multiply them together, log 32 minus log 8. And because we've got a minus 1, we're going to use the second rule and go log of 32 divided by 8 equals log 4. Part B here, you might think that you might be using the second rule here. However, that says the log of A over B. It is not the log of A divided by the log of B. So we have to be careful with these ones. What we want to do when we've got a fraction is be able to cancel things out. So if we had it at the same as the log of the same number, then it will cancel out. So what we're going to do is change the top line a little bit and say, right, 27 is 3 to the power of 3. We're going to pull the 3 out the front using the last log rule there at the top. So it becomes 3 log 3 over log 3, and now that they're both log 3, they can now cancel out, and all I'm left with is 3. Right, now we're going to solve equations. When x is the power and it isn't a simple whole number answer. So we can't guess and check. Solve by taking the logs of both sides. So we've got these 4 here. So first of all, we've got 3 to the power of x equals 21. This is when I said that this is probably when we're going to use logs the most, is when we're solving for x being a power. So what we're going to do first, take the logs of both sides. Okay, and we end up with log 3 to the power of x equals log 21. This is the step that we take next. We bring our x down the front using that third log property from the previous page. So the x comes down the front, so it becomes x log 3 equals log 21. That's x times log 3, by the way, too. So to get rid of times by log 3, you just divide it through the other side. And at the moment, we just put it into the calculator then, and we get an answer of 2.77. Okay, we do the same for the second one. So we take the logs of both sides, the x comes down the front, so it becomes x log 2 equals log 30. Divide by the log 2 through both sides, so we ends up on the second side. Log 30 divided by log 2 equals 4.91. So look at this one, same principles apply. We've just got not just x there, but we just use the same properties. So we're going to log both sides, pull the 4x minus 5 out to the front, times it by log 13 equals log 6. Divide by log 13 to get rid of that over to the right hand side. So we're left with 4x minus 5. Work out that number as it is at the moment, so it's 0.699. Just be careful to give a few decimal places, because otherwise when we do some more working further on, the answer becomes less accurate. So now we get rid of the minus 5 by adding 5, and the last step, of course, is to divide by 4. and we get x equals 1.42. Right, now we're going to evaluate this one here. So put it equal to x, change it into the index form. So the base is 4, my power is going to be x, it equals 128. Now it looks like the ones in A and B. So log both sides, bring the x down the front so it becomes x log 4 equals log 128. Divide by log 4 and work that out on the calculator as being x is 3.5. And that's the use of logs.